A system is a set of parts working together to achieve a goal. Think of it like a team. Each member has a role. When everyone does their part, the team succeeds. Systems are everywhere. They can be simple, like a bicycle, or complex, like the human body. Systems solve problems or perform tasks. They take inputs, process them, and produce outputs. For example, a coffee maker takes coffee beans and water and makes coffee. Understanding systems is crucial today. We use many systems daily, like buses and phones. By understanding systems, we can use them better and make informed decisions. Systems, no matter how complex, share some common traits. These traits help us understand how systems function and interact with their environment. First, systems have a clear purpose or goal. For example, a car's goal is to transport people. Second, systems consist of connected parts. These parts work together to achieve the system's goal. Third, systems show synergy, meaning the parts together do more than they could alone. Fourth, systems interact with their environment. They take in inputs and produce outputs. Finally, systems have boundaries that define their limits. These boundaries help us distinguish the system from everything else. Every system has three main parts: input, processing, and output. Input is anything that enters the system. This could be raw materials, data, energy, or people's efforts. Processing changes the input into something useful. This could be calculations, sorting, filtering, or other actions. For example, in a factory, raw materials are turned into finished products. Output is the final result after processing. This could be a product, service, information, or a system change. The output is then sent back into the environment. Section 5. Control, feedback, and system boundaries. Control mechanisms ensure the system works correctly. They monitor the system and make changes to keep it running smoothly. Like a thermostat, keeps your room at the right temperature. Feedback is crucial for control. It shows how the system is doing, so we can make improvements. Positive feedback increases output, while negative feedback keeps the system stable. System boundaries define what is inside and outside the system. Knowing these boundaries helps us manage systems better. The environment is everything outside the system that can affect it. Section 6. Different types of systems. Systems can be grouped into different types based on how they work and what they do. Physical systems, like factory machines or a forest, have real, touchable parts. Abstract systems, like software or math equations, deal with ideas and information. Open systems interact with their surroundings, exchanging energy, materials, or information. Closed systems are isolated and don't interact with their environment. Most real-world systems are open systems, always interacting with their surroundings. Knowing the type of system helps you study, design, or manage it better. Section 7. System Analysis and Design. A blueprint for success. Before starting any project, it's important to plan and design carefully. This is where System Analysis and Design, or SAD, comes in. SAD helps us understand a problem, figure out what we need, and design a system that works. System analysis means looking at the current system, seeing what works and what doesn't, and understanding user needs. System design is about planning the new system, showing its parts, what they do, and how they work together. Section 8. The importance of planning in system development. Planning is crucial in any system development project. It gives you a clear path to follow, from identifying the problem to creating the solution. Without a solid plan, projects can become chaotic and unmanageable. Good planning ensures everyone knows their tasks, resources are used efficiently, and issues are identified early. It involves setting clear goals, defining the project scope, creating a realistic schedule, and assigning roles. Investing time in planning can save a lot of time, money, and effort later on. Chapter 9. The System Development Life Cycle, or SDLC. The SDLC is a process to create and manage information systems. It has different stages, each with specific tasks. The main stages are planning, analysis, design, implementation, and maintenance. In planning, we decide the project's goals and check if it's doable. Analysis is about understanding user needs and current systems. In design, we create technical plans for the new system. Implementation is where we write code, test it, and launch the system. Maintenance keeps the system running and updates it when needed. Section 10. The importance of SDLC in a technology-driven world. In today's fast-changing tech world, the SDLC is super important. Companies use technology to work better, make customers happy, and stay ahead of others. A clear SDLC plan helps build systems that meet user needs. It reduces problems, handles tough tasks, and helps teams work together. By following the SDLC, companies can manage complex projects and innovate successfully.